Hi, everyone. Good morning. Welcome to section 9.4, part 5. This is the last video. I know it's been a whole lot of information, but I am pretty excited about it because most of this information should be brand new to you, and it will help you so much as you guys move up in your math career. So I'm using Zoom to record this for the first time, so let's see how it goes. All right, so let me share my screen with you. Okay, I am on page 488, and I want you to take a look at the core concept. Now we're going to be translating. Let me go here. Oops, not that. Let me go here. All right, let's review something. So here we have our parent sine and cosine, and I wanted to clarify a few things here. The parent function for the sine starts here at 0, right? And the x-axis, this is called the midline. We'll cover that in a second. And it goes up to a maximum, right? And then it comes back down, curves here to the minimum. And one full period stops here at 2 pi, okay? So same thing with cosine, except it starts up here at the top of the maximum, right? And then one full period as it moves down, again, stops here for one full one at 2 pi. Okay, so here's some notes I want you to take and copy down, please. Super important. Okay, so when we're translating, which means we're going to be moving the parent function up, down, left, and right. So the previous video we did stretches and shrinks. So I'm going to highlight a few things here so it makes some sense to you. Okay, so A, review. The number that sits here is the amplitude, right? And remember, the amplitude is the distance from the midline, from the x-axis, up to the highest point. Okay, that's it. Next is B. B, which sits right here in front. Oops, I was going to change colors. Okay, that is how many periods fit in between 0 and 2 pi. I know that I mentioned that in a previous video, but I didn't highlight it. So, and remember the formula to find the period is going to be 2 pi divided by the absolute value of B. Okay, I didn't add this last part here, which is K. And I think you guys know K pretty well from all the translations that we've done in the past. We've done quadratics, we've done exponential, we've done logarithmic. So this should be a pretty easy transition. It's just learning the new function. Okay, so let's go back to the core concept, and I'm on page 488. Let me share my screen with you. I'm going to point out a few things to you. Okay, now the midline is going to be the the vertical translation up and down. Okay, so this K part, you're very familiar with that. Usually most kids do really well. Okay, so remember, if K is positive, it moves up. If K is negative, right, it moves down. Now, I'm going to show you, oops, let's take a look at what we've done before. Okay, so different teachers have different ways of explaining it. And if you watch Mr. Mitchell's videos, he talks about these being mountains, right? And these being valleys. And the midline being sea level right here for the X. So that's how he refers to it. I like to talk about him as the maximum, the minimum, and the midline right here, which is in between, halfway in between the maximum and the minimum. Okay, so going back to the core concept. We already know what the amplitude is, got that. Already know what the period is, got that. All right, the horizontal shift right here. Okay, that is H. It's on the inside. So it's really important to know that the parentheses right here talks about the horizontal shift. If it's minus H, remember this one is to the right. If it's plus H, right? Let's say it's plus H. If it's to the left. So for sine and cosine, and A is the amplitude, which is the distance from the midline to the maximum point or the minimum point. Okay, now let's go on to Let me show you these. Okay, so this is also in your book. I wanted to highlight it because it's important. There's some new vocabulary here. It is called a phase shift. Okay, your phase shift is your horizontal translation, left and right. And it's really important because with quadratics, you can see the shift left and right really easy. But with sine and cosine, you may have to shift it over so much that it looks the same as the original because it's a repeating pattern. Okay, so we'll do more for that. We'll do more of that. Again, here is the K's again pointing. This is the vertical shift, up or down, right? So that would be up, and then this one is minus h, which is going to be right or left. Okay. Now let's do some problems. And oh, let's open up your, let me open up Desmos so that we can see it in Desmos. Share my screen, Chrome. Okay, so if you're opening up Desmos for the first time, make sure that you set the settings. So we'll do that. Right up here, go to your toolbar. Remember the x-axis is going to be negative 2 pi to positive 2 pi. The y-axis, we don't need that, but what's really important is this step here, right? It's going to be pi over 6. Now, also make sure that it's here in radians. All right. So the first problem that we're going to do here is going to be a vertical translation. Let me put in the parent function, y equals sine of x. Sine of x. Good. And I'm doing example 3. I'm on page 489. Okay, so y equals 2 sine of 4x plus 3. All right, so let's talk about these. I'm going to write it here. Let me see. All right, we can just talk about it here. So A is the amplitude, okay, which is 2. Okay, so here's my original. Let's look at it. It's a, well, actually the easiest one to start with is going to be the plus 3. All right, so we look here at the original, at the origin, 0. This is where it starts for the sine function. And then it's going to move up 3, which you can see here, 0, 3. Okay, so that works. Now, 2 is again the height. So that means from the midline, here, let me put another midline in here. Y equals 3. All right, the green line. There's my midline. So from the midline to the highest point, right, the maximum, it's going to be 2. Yes, it is. Let me zoom in for my numbers. 3, 4, 5, that's 2. Perfect. Okay, so 4x. So 4 is how many times, that's going to be my B, how many times you see a period between 0 and 2 pi. So now I have to zoom back out because I want you to be able to see this. Right there. And I'm going to scoot it over here. Okay, so here's my 2 pi. Really want to write on here. I recorded pretty much the whole lesson, and then I realized that I was having technical problems and it wasn't showing the math. So I'm going to redo this again so that you guys can see the math. It's super important to see it. Okay, so for example 3, it says to identify the amplitude, period, horizontal shift, and vertical shift. So amplitude should be easy. Amplitude is 2, right? We talked about that already. Now let's find the period. So again, the period is going to be 2 pi divided by the absolute value of b. And b in this case is going to be 4. So let's do some math here. The period is going to be 2 pi divided by 4, right? So that means my period is going to be pi over 2. So let's look at that. Period is going to be from pi over 2. So 1 full cycle starting here. And there wasn't a horizontal shift, so we can start here at the origin. We moved up here. Remember, sine starts down here at the midline. It's going to go up to the maximum, down to the minimum, and then right here is pi over 2. Perfect. So we have the right period. So let's talk about the horizontal shift and the vertical. So horizontally shifting it, if you take a look, it did not move horizontally. So there is no horizontal shift, right? Because h equals 0. And then k, that's the easy one for everyone, is going to be up 3, right? Because of this. Perfect. Okay, so here's example 4 in your book. It's graphing horizontal translations. Again, the red line is my parent function. Always important to see the parent function. And here is the graph of example 4. All right, so let's identify again the amplitude, period, horizontal, vertical shift. Okay, amplitude. Amplitude should be pretty easy. Oh, and I did not put in, well, I'll do it afterwards. We'll put in our midline in a second. So amplitude is 5. And you can see from the midline, which is right here, it is between 0 and 5. Perfect. Now let's find the period. Okay, now B. In this problem, B is going to be 1/2. Now let's remember, it's 2 pi over the absolute value of B. Okay, here's the math. So 2 pi divided by 1/2, remember, multiply the reciprocal, and that's going to be 4 pi. All right, so what does that mean? That means that in one cycle, okay, one period, it's going to be between 0 and 4 pi. So let's take a look at that. Okay, so this is a little different, because you can't just start at the origin because it's cosine. And if you look at the original, the parent one, it doesn't start, the period doesn't start at the midline. It actually starts at the maximum. So let's take a look at this. I'm going to go here. Here's my first maximum. Okay, so my first maximum is here at 3 pi. All right, so let's do one cycle. We're going to go down here to the minimum through the midline, back up through the midline, back up to the maximum. So for cosine, that is going to be one period. And where does it stop here? Well, this is 4 pi, 5 pi, 6 pi. This is going to be 7 pi. Well, if you subtract the two, 7 pi minus 3 pi, there you get your 4 pi, which is one period. Perfect. And let's do the horizontal shift. Okay, so remember the horizontal shift is right here. And because it's negative, it's going to the right by 3 pi. And let's do the vertical shift, and k in this situation is going to be 0. So there is no vertical shift left and right, which means I can put my midline up here since it was 0. Y equals 0. And there's my midline. All right, so let's do this last part. I'm on page 490, and it's going to be the reflection. And again, I know that you guys are going to do great on this because you guys have nailed all your transformations before. So let me share my screen. Make sure you have your book open so that you can see it. And I want you just to take a look here at the graph. So up at the top, you're going to see this is the reflection of sine. Okay, and then here's the reflection of cosine. So A, remember A, the absolute value of A is the amplitude, right? And if there's a negative in front, that's going to show that it's a reflection. Here's example 5. I'm on page 490 if you guys want to follow along. Again, we have to identify the amplitude, the period, horizontal shift, and the vertical shift. Okay, amplitude again. So, well, first thing I want to show you is that here's my parent function sine. It's my red one. Okay. What I did was, since this is a reflection, I did the same function without the reflection, and I want you to take a look at it as we talk about the different parts. Okay, so here's the blue one. That's without the reflection. Okay, so the amplitude is right here in front. It's going to be 2. Right? It's absolute value of A. And then the period is going to be 2 pi over B. And in this situation, B is going to be 2/3. So let's do some math here. 2 pi over 2/3. Remember, you flip it. 2 pi times 3 over 2, right? Those cancel out. So my period is going to be 3 pi. Okay, and what does that mean again? Remember, the period is 3 pi, so between the start of the sine function, okay, which is going to be right here at the midline. So let's take a look now only at the non-reflected one so that we're going to double check that our period is correct. So between the midline, oh, but there's a shift here, right? Because this is where the original one, so it's right here. Let me zoom in so you could see the numbers a little better. All right, and scoot it over. So the shift here is actually going to start right here because of the shift. So we can talk about the shift, right? So it is to the right, right? Pi over 2 units. So that's why it's right here instead of the original, which is right here. So let's look at one of the periods. It says 3 pi. So from here, pi over 2, I'll write it so you can see it. This goes up to the maximum, down through the midline to the minimum, and then right over here. And that is 7 pi over 2. Okay, so if we subtract the 2, 7 pi over 2 minus pi over 2, right, 1 pi, which makes 6 pi over 2, which makes 3 pi. There's my period. Perfect. Now, vertical translation. Since k is 0, there is no vertical translation. But now let's do the reflection, and I want you to see that. I'll clear my work here. All right, so here it is without the reflection. Here it is with the reflection. It kind of comes out to be a really cool, cool graph. So that's the reflection. So here is the original one. So we've identified the amplitude, the period. You have to say that it's a reflection also. So I do not have videos of the monitoring progress. Mr. Mitchell does have them for monitoring progress 5, 6, and 7 if you want to watch his. Or you can watch the Big Ideas videos that they have posted in the dynamic textbook. But let's have some fun doing some work, and let me know if you have any questions.